Algebra 1, Lesson 10.5. Hope you guys are doing well. So we have Lesson 5, and then we're actually skipping Lesson 6 and 7, and then we have Lesson 8, which this is kind of like learning some terminology and how to do a couple things. Lesson 5 is also one that I think a lot of you have learned about, but we shall see. This is 10.5, and it's called the Pythagorean Theorem. And I was going to do THM dot. The Pythagorean Theorem. So this involves things called right triangles. So let's go ahead and lay the foundation of a little bit of terminology and how we'll usually refer to things. I'm going to draw a triangle. I'll make it like this. I'm going to do that little thing there. And what that means is this is a right angle. What is a right angle? It is 90 degrees. Right angle is a 90-degree angle. Okay. It's like the angle that a wall makes with the floor, assuming that the wall and the floor are behaving the way that walls and floors should be behaving. Okay? Alright, so that's that. And then I'm going to say that this is point A. Point A, point B, and point C. Okay? Now, the angle here we could also describe as angle A. Okay, it's the angle that is formed by the two sides that go into point A. So then likewise, this angle right here, we could call angle B, and then that right angle is angle C. So this triangle will oftentimes refer to as triangle ABC, or whatever letters are that make up the 3 points of the triangle. Usually math textbooks go with like ABC or EFG, things that are alphabetical like that. Okay, so what the Pythagorean says, so the convention is that capital letters are used for points, or also capital letters are used for angles, and then lowercase letters are used for the side opposite that angle. So like this angle here, what side is that pointing to? It's pointing to that side here, which we would give a lowercase a. And then likewise, angle B, what is it pointing to? Side B over here. Angle C, what is it open to? Side C over here. I guess just for clarity's sake, let me give that C make it a little bit bigger so it's a little more clearly. Capital C for the angle and a lowercase c for the side. So what the Pythagorean theorem says is it says that for any right triangle, we'll say for any right triangle, or any right triangle. So what's a right triangle? A triangle that has a 90-degree angle in it. For any right triangle, a squared plus b squared equals c squared, where a and b are the legs of the triangle, and c is the hypotenuse. And what's the hypotenuse? It's the angle opposite the 90-degree angle. I'm sorry, the side. Sorry if that was really confusing for a second. The side, hypotenuse is the side opposite the 90-degree angle. And that's what the hypotenuse is. Okay, so we have this a squared plus b squared equals c squared that we're able to use to figure out the length of an unknown side of the triangle, provided that we know the length of two of the other sides of the triangle. Okay? And that's what some of the homework problems are like. So, for example, we have stuff like this, like find the length of the unknown side. And let's say we start out with this triangle like this. The triangles, by the way, can be oriented different ways. Sometimes you'll be able to tell what A and B are, sometimes not. You can always tell what C is because it'll be the one that is marked with the right angle. So let's say we know that, well, we'll start with this. Let's say we know that this is 3 and this is 4. Okay? So in this case, we don't know C. Well, we could use Pythagorean theorem. We can say A squared plus B squared equals C squared. Now, do we know which one is A and which one is B? No, but we know that A and B are the two legs, and it doesn't matter if we did 3 squared plus 4 squared versus 4 squared plus 3 squared, we'll get the same thing. So I'm going to say 4 squared plus 3 squared equals C squared. Well, that is 16 plus 9 equals C squared. 16 plus 9 is 25, so 25 equals C squared. Now we want to find what C is. So we
And, yep, so that's what we're going to do. Oh, man. I just realized that I think my microphone wasn't completely plugged in. Maybe. Hopefully it was. If not, everything until now was sounding kind of echoey probably to you. And now it probably sounds a lot clearer. So if that happened, sorry about that, but I'm glad that it's better now. All right. So we have 25 equals c squared. We want to find c. So what we need to do is we need to take the square root of both sides. Now, when we had an unknown squared and we're taking the square root of both sides, what we're supposed to do, let me make that look a little bit more like a c, is do plus or minus the square root of the other side. But here's the deal. What is it that we're finding? We're finding the length of the side of a triangle. And a negative length doesn't make much sense. So because of that, we don't worry about the plus or minus in this context. But in almost every other context, we still have to worry about the plus or minus. So then what's the square root of 25? It is 5. So that is the length. Now 5 is a nice, perfect integer. We didn't have to do any rounding or anything like that. And so that's our answer, just 5. We'll see in, I think, the next example that sometimes you're going to have square roots that are hanging around, and we need to simplify that square root to have an exact answer, and then use our calculator to find out what the rounded value would be. So let's do an example that is like that. So next one, same instructions. I'm just going to draw the triangle now. This one, we're going to have this. And let me make that a little bit taller. 2 and 12. Okay, let's see what we can find. So this time, A or B, and I guess I'll go ahead and say that we'll pretend that this is side A. All right. So then what we can say is we can say that A squared plus, well, I mean the formula A squared plus B squared equals C squared. Let's plug in what we know. We don't know what A is, so we still have A squared. B squared, that's 2 squared, equals C squared, which is 12 squared. So we have A squared plus 4 equals, oh wow, I actually wrote 12 to the 12th. 12 squared, there we go. 12 squared is 144, so 144. So then what do we get? So we would subtract 4 from both sides. So we would get A squared equals 140. Now we need to take the square root of both sides. So I'm going to say A equals the square root of 140. Again, you don't have to put the plus or minus, but in almost every other circumstance, you would have to put plus or minus there. Now, if I take my calculator here and I do square root of 140, I get, let's see, 140. So the square root of that is approximately 11.83215,957, and my calculator stops there, but it keeps going. Okay. We will do a rounded answer in just a moment. But so it's not like 12, okay? Because it's not exactly 12. It's 11.83215,957, and then the numbers keep going on forever. So there's no way to write this exactly as a decimal because at some point you have to round. So this is what we mean by writing the exact answer is 140. The square root of 140 is exact. It is exactly whatever this number is that would keep on going forever. But we have to check, this is lesson 2 kind of stuff. We have to check, can the square root of 140 be simplified? Okay. And so, well, I know that it's divisible by 10, right? Oh, but that doesn't help me because 14 times 10, neither of those are perfect squares. So again, this is drawing on lesson 2 stuff where what you check to see is like, can 140 be written as 4 times something or 2 squared? Can it be written as 9 times something or 3 squared? Can it be written as 16 times something or 4 squared? Can it be written as 25 times something or 5 squared? So I take 140 and I see is it divisible by 4. And I do 140 divided by 4 and I get 35. Ooh, so square root of 140 I can also represent it as the square root of 4 times 35. Let me write that 35 a little bit better. I don't know what happened there. Now the 35 is 7 times 5. Neither of those have 4, 9, 16, 25, any numbers like that as a factor. But I do know the square root of 4 is 2. So a 4 inside becomes a 2 outside. 2 root 35. That is my exact answer. Then my rounded answer I already kind of got up here. I think on this lesson I say to do it to 2 decimal places. So my rounded answer would be 11.83. That's my rounded answer. Okay, so those are your 2 answers. Exact answer and rounded answer. So this one note, we knew the hypotenuse, so we had to be careful is that the hypotenuse we plugged in there. Because this time we knew the hypotenuse. What we didn't know is one of the legs. Okay, so be careful about what you're plugging in where. All right, let's do one more example. Because sometimes maybe one of the sides that you have already has a square root in it. So I'm going to do this one. What do we have here? I have 5b and root 77. Okay, that'll work. So maybe, I don't know, I'll draw it like this time. So let's say this is 5, this is b, and this is root 77. So our formula again, a squared plus b squared equals c squared. Let's plug in what we know. I know a is 5, so that's 5 squared plus b squared. I don't know what b is yet. Equals square root of 77 squared. Okay? All right. Well, 5 squared is 25 plus b squared equals, now again, square root, squaring something that is in a square root, squaring a square root, the squaring and square root basically cancel each other out and it frees whatever was trapped inside. So that leaves us with 77. So subtract 25 from both sides and you get b squared equals, what, 52? 52. And we take the square root of both sides, we get b equals the square root of 52. And we check to see, I check 4 first. Is that divisible? Nope, that is 52. Could be written as 4 times 13. So that's equal to the square root of 4 times 13. 4 inside becomes a 2 outside, not because we're dividing by 2, but because the square root of 4 is 2, equals 2 root 13. That's my exact answer. And then I see what 2 times the square root of 13 is approximately 7.21. 7.21. I don't know, my pen is like doing weird stuff this time. All right. So that's that. And then the one other thing that could come up here is you could run into something where you're looking at a graph and you have to figure out the lengths from there. So let me draw some axes here. Say we have that axis and this axis, x, y, 1, 2, 3, 4, 5, 6, -1, -2, -3, maybe 1, 2, 3, -1, -2, -3. And let's say whatever triangle we have, it goes from maybe this point here out to this point here. And then from there, maybe up to this point here. I'm going to erase that line, draw it a little bit higher. I'm not intending for this to look like it goes through the origin. Okay, good. That doesn't quite look like it goes through the origin. So we're just looking at this graph. Now what we could do is we could figure out what the lengths are that we're dealing with. So this one, there are two ways that you could do. You could say this is going from 1, 2, 3, 4, wait, 1, 2, 3, 4, 5. This is going from an x value of 5. And then it started here at x value of -3. And you can say, what's the difference between 5 and -3? In other words, 5 minus a -3. Or you can just kind of count steps. We're going 1, 2, 3, 4, 5, 6, 7, 8, if you're careful. But personally, I would just say, well, this distance here is 5, and then I'm going another 3 steps. The total number of steps I'm taking here is 8. And then here, I'm taking 2 steps to get up to there, and then another 3 steps. So the total number of steps that I'm taking here is 5. And we want to find how long the hypotenuse is. That's like what this problem would be saying. How long is the hypotenuse? Well, let's plug in what we know. Get our formula, a squared plus b squared equals c squared. So it doesn't matter. I have the two lengths, or sorry, the two legs of the right triangle. It doesn't matter if you say 8 squared plus 5 squared versus 5 squared plus 8 squared. I'm going to say 8 squared plus 5 squared equals c squared. So that is 64 plus 25 equals c squared. So what I have there, 89. 89 equals c squared. It's not going to be divisible by 4 or 2 squared. 89, yeah, definitely not divisible by 4. So the next perfect square up is divisible by 9. It's not divisible by 9. Then I can check 16. It's not divisible by 16. If it's not divisible by 4, it's not going to be divisible by 16. It's not divisible by 25, that's for sure. And the next one up after would be 36. It's not going to be divisible by 36. So this, yep, so I have root 89 equals c. That's my exact answer. And then if we see what the rounded value is, square root of 89 is approximately 9.43. So 9.43 would be my rounded answer. Okay. The textbook has some problems that it's like, here are 3 values. Determine if this could be a right triangle or not. And you would do like the smallest one squared plus the next smallest one squared equals the longest one squared, and see if they're equal. If the longest one squared equals the 2 smallest ones squared. And if they're equal, yes, it can be a right triangle. If they're not, no, it's not. But I don't have any of those for you. But I thought I would still put it on your radar that it's still something you can do with the Pythagorean theorem, is verify whether or not something is a right triangle. Okay, hope that makes sense. Hope this lesson is fairly quick and easy for you. But as always, let me know if you have questions. Okay, cool. Bye.